Hey everybody, this is Larry. This is me over Q4 of the weekly contest 250 maximum genetic difference query. So this one, first of all, hit the like button to subscribe and join me on Discord. We usually go over a lot of people talk about the problems right after the contest on my Discord. So if that's your thing, you find yourself wanting to talk about problems, come join us on Discord. Anyway, so for this problem, the first thing I'm going to go over very briefly, because I think there's already a video on this, is oh, maximum XOR with an element from array problem. So yeah, so try to find, I'll put a link somewhere, but on the description or something. But yeah, watch the video on that one. I think that's instructive to figure out the XOR. I have the code here, and and I actually wrote really good code to kind of have a try. I have nodes, and then I have all these things to. But basically, this is just a try and maximizing it. I go over the logic behind this as well. So yeah, so definitely check it out there. But the short answer is that okay, you create a try, you find a greedy solution for each query, and yeah, you construct a tree first, and then for each query you kind of bit by bit do greedy on the high order bits first, and then you get the answer that way. Again, I know that my explanation may be really fast. Definitely check out that video, and that is maximum XOR element from array. It's a hard problem, so if you don't get that one, it's hard to solve this one, so definitely go over that one first. Again, I'll put a link somewhere. Okay, so let's say you already know that one. Then it turns out that for this particular problem, and also let me show you real quick. I actually solved this in Python, and I got time limit exceeded. Mostly because I did try a node using its own class, and it's a little bit expensive, but it really should not be an issue. But in Leetcode specifically, it's a performance issue, so I don't know. But this is how you write in Python. You have some try and node. Again, watch that video if you wanted me to show you the code, but I actually end up solving it by converting to C#. And the reason why I'm bringing this up is that that's why I rewrote the code here in a yucky way, and you get to watch me solve it live during the virtual contest next. But that's why that I wrote it like this instead of using a try class and a node class. But anyway, so that disclaimer aside, so the way here is that so you're trying to, for each query, you're trying to find the sub part of the tree that is that you can answer that maximum XOR for. So for this problem, and this is something that I really find annoying sometimes, to be honest, which is that they have these, like data structure E things, and then a list of queries. And the assumption there is that you do the queries as they're given to you because it feels like an interactive problem in life, or like if you're doing like a software engineering thing. In queries, when you get them, you already have this thing, and you want to pre-process in a way such that you're able to answer these queries, and it's just like a pseudo substitute for that, right? However, for competitive programming and maybe Leetcode in general, there is a trick, and it's a weird trick, it's an annoying trick, which is that you don't actually have to do these in order. So that means that you're able to, kind of do these queries in any order that you like, even if it means pre-processing or processing the data structure in a way that answers the queries as you're processing. It's a little bit crappy if you ask me, because I feel like it's not really in the spirit of how the structure is, but it is a problem that you get sometimes on Leetcode or on competitive. And anyway, so here, the key thing is that, yeah, so you reorder the queries in a way such that you can solve the queries as you're constructing the data structure. And here, as I kind of gave a hint before, let's say you already know maximum XOR with elements from array, and you have that data structure, right? Meaning that you created a try, then the nodes, and you're able to get the max given a try. And these are the code here. Again, there's a video on that. But yeah, so you have the max given a try. But so for here, basically the answer here is that you construct a tree partially. You construct a try partially, and then answer the query as you at that exact moment where you have all the tree constructed, or all the try of the path constructed. And what I mean by that is, okay, and this is just a very standard breadth first search or in order to, is it in order? No, it's pre-order traversal. You do a pre-order traversal of the tree, and then at every step of the way, you have a partial data structure that you're able to answer all the queries at that time. And what do I mean by that? Let's take a look at this example 2, right? That means that if you look at a pre-order traversal, first you have 2. If you're at the number 2, you answer all queries that have 2 as the node, right? And then you add the number 2 to a try. Okay, let's say we now process 7. So at 7, you have a data structure that has the number 2 in it, and then you add the number 7 in it, right? Okay, you do those 2 things, and then now you process all the queries that have the number 7 in it. Okay, next, you add the number 1. Now, you process all the queries that have number 1 in it. And in this case, there is, right? And here, there's 15. So then now you do the try thing, which means that, you have a partial data structure that allows you to answer 15 with the numbers 2, 7, and 1 in the try. That's basically the answer. And then now, as a pre-order traversal, now 1 is a leave, so now you pop back off. So now you remove 1 back, you get to the 7. Of course, you don't need to do anything more because you already did the 7. And then go to the 5. So now you remove the 1, you add the 5, and then now you process everything with the node on 5 on it. So that's basically the idea. You can go through it, the rest of that. That's basically the idea for this problem. And again, my code is a little bit weird because, like I said, I was worrying about time limit exceeded because Python on Leetcode is a little bit weird. So I'm going to go over my code now. So you can think about each node. Each node has, let's just say X, Y, Z, where X is the 0 leaf or 0 child. Y is the 1 child, and Z is the number of sub-children or descendants of on this node, right? And of course, if this doesn't mean anything to you, again, I explained it on the previous video under here, so you need to build off that. That's why I keep on saying. So yeah, go there and check it out. And okay, and here I just we're given children and their parents, so this is just inverting it so that now we have the parents to the children. Here we the root has a -1 as the parent, so that's basically what I set up here. The root is the children of the parent of -1, and it should only have 1 node, so that's basically the root, right? Here we're processing the query in a reverse kind of way, meaning that for each query we set it to the node that we care about, and we append both the value, which is the query, and the index so that we can return the answer according to this index in the future. Add and remove is what we said earlier with respect to add and remove a number to try. If this looks a little bit awkward to you, like I said, watch the other video. The only thing that is a little bit different is that I kept the number of children here on that subtree, and then for adding, and then for removing, I remove it, and then I just move down the list. And this is just going down the list, the traversal of the tree. And then get max. This is also pretty much functionally the same as the one I have in the other thing, right? Actually, I even have a get max function. It's just that I rewrote it in a different way. But basically, the idea here, and I do go over in the other video, but the idea here is that, let's say you're trying to find a max value of some number here, then in a greedy kind of way, we will try to go, what will the max, or the most significant bit, the max number will, if we greedily, we'll choose to go down 0 if we want to, because the XOR of these two numbers will be equal to 1 if we go down 0. If we cannot go down 0, then we go down 1, right? So that's basically the idea here, is that, okay, if this number is 0, or sorry, if this number is 1, then we try to go down 0. And that is part of your max answer. Otherwise, then we don't have any digit here. And then in the inverse way, if this number is 0, then we try to go down 1, and so forth. Again, this is explained in the other video. I'm a little bit tired right now, I apologize. But that's basically the idea of get max. And then here is just the depth first search of the queries. Here we just allocate space for the answer. And then from that, we have a depth first search that goes, we add the node as in the beginning. We answer all the queries for that node, and then we do a preorder traversal, and then we remove that node at the very end. And then we start from the root, and then we can process the answer. And that's pretty much it. So to go over the complexity really quick, the add function has an O of 18, which is the number of bits. This is an 18 loop for loop, and each of these is O of 1. So this is going to be O of 18 or O of 1, or the number of bits, if you want to say. Same as remove, this is just, O of the number of bits, and also get max, because you can kind of see the for loops and just, number of constant operations there. So then that means that for each query, we call get max ones, and for each node, we go add and remove ones. So this is going to be linear. Linear times the number of bits, so this is linear time, and space is going to be 1, also linear times the number of bits, because you can imagine, they're that long, and so linear times the number of bits for both time and space, and that's pretty much all I have for this one. Let me know what you think. Hit the like button, hit the subscribe button. Watch me solve it live to the contest next. I think I explained it pretty okay live, maybe, because this is a virtual contest, so I definitely slowed down to do some explanation. Watch me solve it live next. What a sloppiness. Okay, let's go. Q4. Let's refresh real quick, as I usually do. Though usually I refresh to kind of see how hard it is. So that's kind of, and we can spend some time refreshing this one to kind of just see how hard it is in my current time. Some people already finished. Okay, so I'm not that far behind, though I really should have gone Q3 earlier because I have most of that math. But okay, Q4, a lot of people did it in 10 minutes, so I probably will have to spend some time. Okay, maximum genetic difference query. Let's see. Generic, each node's number is a unique genetic value. The genetic difference between two genetic values, the bitwise. Okay. What does that mean? Okay. For each query. Okay, what is going on? So, okay, so we have this tree. Let's see. This is a lot of, I have to think about this. It's a little bit late in the night. The node of the, okay. I have to slow down and really read this. Okay. Okay, so the difference is XOR. Each node has its value as an X. Okay, the parents I know, what's a query? Find the maximum genetic difference between Y and P sub I, where P sub I is the genetic value of any node. It's P sub. Okay. And the root on the path between, okay, so we're given node and the root. Wait, what? The node. Okay. So basically, if, I mean, I'm sure that the constraints that are weird enough that you cannot do this brute force. But the brute force way to do it is, this is very hard to read, but you find a node and then you just keep going up. Like you basically have a list, you do the maximum, you do a max over the XOR of all the things to the number. Okay. Okay, let's look at the constraint to see anything I can abuse. All the numbers look pretty okay. I mean, this is a tree. Oh no, well, you have to construct a tree. And you have, well, I guess half an hour in, only 9 people got it right. And even people who are really fast on Q3. So, okay. Let's see. So, okay, so let's say 4. Where's 4? 4 is there. 6, you just go up to this. Yeah, you go, okay. I think I know what the problem is asking for now. Do I know how to solve it? Probably not. I mean, one thought I might have is binary lifting, but I feel like that's too crazy. But also just, the value is 2 times 10 to the 5th. Is that something I can abuse? A 10 to the 5th number of elements. How much time do I have left? I actually don't know, because usually I start, at the same time. But here in this particular one, 58 minutes. So I have an hour left. And okay, so node 1 and value 15, you just go up, and I guess that's true. I mean, can you build a try in a weird way? Maximizing, so the thing I would say that is that usually when you want to maximize XOR, usually a try is usually related to a try. Is there anything I can take advantage of this? Because there's only a set amount of possible answers from that. And you have to do it on each node, maybe? Well, what's 2 times 10 to the 5th? 20,000. So that's 16, 2 to the 16, 16 bits. Can we do something 16 bits for each query? Yeah, probably. That should be fast enough, but how do we store it? Okay, so looking up the node is pretty straightforward, probably. But how do we reuse? Can we even reuse answer? This is a hard one. I don't know that I even have any idea. Though 210 pure salvage, though, that's a cheating way of. For each query, I mean, this is a hard problem, even if you just give me a list of numbers and not like structured like this. But oh, so one technique that I think I always forget when it comes to queries is that Okay. Is that you don't have to do queries live, meaning you don't have to pre-process and do the queries, because in competitive is cheating. So can we do this recursively? No way. Yeah, we could do this recursively. Then we can just build a try, and as we build the try recursively in a depth first search, so it's just a lot of code. So what I would do is we build the try recursively, and as we do that, we are able to do the queries and do that in a way. Is that weird? Yeah, I think that's the way to do it, though it's really annoying, to be frank. So you build a try interactively and then process the queries also as you're building that try, as you're going through that thing recursively. Okay, I think that's the way to do it, but I'm just trying to think whether, I guess that's the way to do it. It's just annoying. That's probably why people took a while. It's not impossible. I think if I had pre-win code, and I kind of do have pre-win code, but I don't. Yeah. I also worry that the general thing is too messy, but okay. Because so one concern I have, and this is Leetcode specific to be honest, is that, and I've done a similar problem to this in the past, and it's too slow because I had explicit tries and nodes instead of implicit tries and nodes. And I never learned how to do it implicitly because it's really bad code, but in Leetcode you need it to be performant. So that's why I'm like hesitating a little bit and trying to think about how to implement this in a good way. Yeah, okay. Let me try to think about this, how to, but yeah, so basically, okay, let's just think about it. So now we have some add function. So head is equal to, yeah, now just two nodes, right? So none, say, and then now for, okay, I mean, I know how to do this. It's just yucky. Yucky, 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 yucky. Okay, let's just have two function, add a number. Yeah, let's add a number, which is, what's 2 times 10 to the 5th? 10 to the 5th. Okay, so I actually was wrong about the 16 because I think I missed the decimal. But what is that? 2 to the 15? No, 2 to the 18? 2 to the 18 is big enough, right? So okay, let's choose 18 as the const. Yeah. So then now we just go, okay. This is just like really, because the problem right now is that I'm trying to optimize, prematurely optimize, to be frank. But what an annoying problem. It's just really, really, like, now that I get it, I also know that implementation is a little tricky, but that's fine. I've done it before. I don't know why I'm being a little nutty about it. Let's just say, let's just, so we want the big bit. Yeah, okay. If this is greater than 0, I've written this code before too. That's the sad thing. That means this is a 1, so we want if oh, this is bad. No, this is oof. Yeah, okay, fine. If I is none, then has of I is equal to oh wait, what am I doing? This is oh no, this is what am I doing? Okay, I'm just being really bad about it. Even though I know how to do it, and hours should be way more than enough time, to be frank. And then current is equal to current minus 1. Okay, yeah. Let's just say j is equal to what? I could probably write this much better, but it is what it is. I think this is good. And then at the very end, I have to set something, don't I, in a better way. This is why I usually have a structure, but okay, fine. Let's just say force currents of 2 is equal to true, something like this. That's why I usually have a structure. I'm writing really ugly code right now, to be honest, but okay. And then now, okay, I'm just going to try my double test my API for a second. I know that there's a lot of things to do. This is a lot of coding, but it's not it's okay. Let's see if this gives me any error. If it's okay, it's okay. Okay, fine. Let's even print head. This actually, this may be really big because it has a lot of okay, and I'm correct. Why is this? Oh yeah, right. Should have 1, 2, 3, 4. So that's 4 numbers. Okay, I think this is actually maybe what I expect, give or take. Okay, so that's good. Okay, remove is the same. I probably should do a traversal of this. Yeah, remove should be okay. Okay, so okay. But that's not good enough, is it? Because on remove, you need to propagate up to remove. I guess we could have a. I'm like writing such terrible code. Actually, we could just add this to 0. This is none. Then we could. Then there's a path in there, so that's this. Okay, I think this traverse is a little bit bad. It's not a little bit bad, but we need to be more specific. So let's do that. Otherwise, current sub j of 2 plus 1. But I think this should never be the case, so that's fine there. Okay. Okay. Again, I'm writing really bad code, but let's try it again. I'm going to take my time. How much time do I have left? 44 minutes. Okay, and okay, so this should give me no error, and it doesn't, so that's good. Okay, and then now we want the maximizer. I think with the queries is actually okay, so I don't need to do the maximizer yet. But let's build the tree then. Okay. How do we build the tree? Such a weird problem, which is an annoying problem. Because now we want the children, right? So okay, fine. Okay. So children is equal to and then for index parent in enumerate parents children of index, or wait, no, parent is equal to index, right? I think that's right. Yeah, so 30 means that the 3 is okay. And what's the root? Root is the one where it's -1. Okay, so that's fine. So yeah, root is equal to children of -1 should only have one element. So let's just do that. Okay, let's just sorry. Let's print out children real quick. Okay, so yeah, root 1 is 0, 0, 1, 2. So this looks like that. Okay, 3 is the okay, so the root is 2 and 2 has 3, 7. Okay, so I think this is a good, so I did okay here. Yeah, I think I'm good on the implementation of this children parsing. And then now we have to do recursion on, or depth first search on this. So now let's just do a depth first search. Well, let's actually process the queries first. So let's just, okay, so for index of query index, query and enumerate queries. Actually, query is node and value. Okay, fine. Node and value. So then now we want to set. Let's just. I'm lazy with the name, so let's just do this for now. Yeah. And then okay. Yeah, okay, now I'm good. I'm just double checking. So Q of the node, when we process the node, we have to process this. Append value index. I think this is good enough. Okay, so then answer is just equal to an array times the length of queries. And then we return answer. That's good. So then now so we go through the node recursively. DFS of node, and we want DFS the root, which we have the variable for. So here we go, we add node.value, right? Is that, no, well, this isn't a real node, so actually, yeah, we add the node, we want to remove it afterwards, but we want to go for x in children of node, we do DFS of x. Okay, so that's good, but we actually want to do a processing before we do a DFS, and that is okay. Answer queries maybe. Okay, so that means that for value index in Q sub node, we want to get max. No, this is a terrible name, but that's fine. Get max of value. Answer of index is equal to get max of value. And I think we're done here effectively, But the annoying thing is that I think this is another Leetcode problem, is to get max thing, which is that now we go through the list. So I think it's not that bad, but it's just really annoying, like everything about this problem. And then now, okay, if this is a, okay, let's think about this, right? If this is, why am I x? This is, okay, let's just call this an x. Okay, if there's a 1, our max XOR, we want to optimize for 0, right? So if current sub 0, if that value, which is the second value, I know my code is bad, my bad, is greater than 0, then we go down that path. Yeah, and j is equal to, then we go down the 0 path. We want to get the ends. Wait, do we return the max difference or return the number? Find the max difference. Okay, so that means that if this is if we want to go down the 0 path, then we have a 1 in this digit. So okay, so we do this. Well, no, that's not the answer. Okay, but then j, we want to go to 0. Otherwise, j is equal to 1, and we don't change the answer. Else, if x is digit is 1, if we go to 1, then j we go to 1 and answer right? I think this is roughly right. It might not actually be right, but okay, none object is not. Oh yeah, that's right. I have to check for the none. If current sub-0 is not none, and this is the case, what happens if the entire both path is not 0? Is that possible? No, we always have at least one number, so we should be able to go down one path, right? 225, is that even right? Nope. Okay, we did a lot of stuff. We're happy about it, but not that happy about it. But you know, yeah. Why is this wrong? What is the answer for here? Okay. I don't have a good visualization. I mean, this is not that hard to debug, to be honest, but yeah. Okay. Let's look up here. Look up value, well, index the value, and let's just look up the curve. Oh, this may be a little bit crappy, but curve is not in play, of course not. What is this? Oh, head. This is not going to be that readable, but I think we're close. But yeah. Let's see. The thing is, this is like printed out in a very weird way. So okay, so the second we go 5. Okay, on 0, what happens? On 0, the tree should be on. What is this 0 for? Oh, what is this 0 for? Did I mess this up? Oh, I see. I don't have a number on the top. So I need to increment. I need to increment before this. So yeah, on the root. Does that matter? Shouldn't matter, right? Left, right. Oh, this part. 0 is not none. Yeah, that shouldn't matter. Okay, I don't think that matters, but okay, let's try to print it out. Ugh, this is so annoying. Let's see, I and J and Z. Okay, so what are we looking at? So, okay, so when we look up the 2, no, 2 is the, no, we're looking up a 5. In this case, we're looking up the 2, so it should have 0, 1, 2. So 0, 1, 2. What? Did I mess up something? I mean, I could have messed up something, but I don't know how I'm printing this out. Okay, so it gets 0, 0, 0, 0, 0. It goes on 0 until it gets the 2, the second digit. Here the J is 0, because for 5 we want to go to 0, because 5 is 1, 1, 0, 1. This is no good, so we still get 0. What numbers do we have here after the 2? The 2 should have 0, 1, 2. So yeah. So there's 0, 1, 2. And it should match 0, 1, 2 with a 5, so it should match the 2. Yeah, that sounds right. Yeah, that sounds right. But why does it go 0? Oh, going 0 is right. This should go 1, I think, because there should be a 2 in there. Dun dun dun. Is my depth first search incorrect? No, it should be okay. The depth first search is pretty good, I think. I feel like I'm close, but okay. Still have half an hour. I'm okay on time in terms of finishing. So ref I, ref J. The answer okay, so we definitely take this digit. We take this one as well. Oh, we don't take 1, but we take the thing. So that means that we're missing the 2 somehow. And we definitely have 3 numbers somewhere, but can I add this to be more debuggable? Let's see. I'm just doing this to be debuggable, but it's going to be a mess, to be honest. I mean, this should be the last element removed, so I think I could just pop that. I could be wrong on this debugging, to be honest. Yeah. 0, 0. Oh, why does this only have 2? Maybe that's actually fine. Okay, 0, 2, 3. What? No, there's no case in which we have 0, 2, and 3, unless I'm adding the wrong number. It should have. Okay, let's look back a second. Coding is so hard, right? 0, 1, 2 is fine. Okay, there's no 0, 3. Maybe I just misread what I was saying. Or maybe I was looking at the wrong thing altogether. So 0, 1, and 2. So that's right. Okay, so let's print that out then. Where's my print? Look up get max. So here we can print out. Oh, am I dumb? I am dumb. I forgot to shift the current. That's why. Okay. Okay. Hopefully, maybe that's it. That is a dumb typo, though. Let's see. Okay. Do I have the right answer? I think I have the right answer. Okay. Wow, I am dumb. Let's now clean up the code a little bit, or my debugging code. I might need it again, to be honest, but we'll keep our fingers crossed and just hope we don't need it again. I have more debugging stuff, but let's get rid of this. Do I? Do I have no more print statements? I thought I have more. Line 4. What did I do? Oh, whoops. Okay, so I think I'm mostly done, but line 27. Oh, how did that happen twice in a row? Oh, maybe auto complete type things auto deleted my bracketing. Okay, so this looks good. Is it fast enough? Probably. If not, then I'm just, I don't know, YOLO. Fingers crossed. I mean, this is okay. But yeah, hit the like button, hit the subscribe, and join me on Discord. Let me know what you think about this problem, explanation, whatever you need to do. I'll see you later. Stay good, stay healthy, and I'll see you later. Bye bye.